Hello, welcome to video number 60. I'm Mr. Miller, and you are one of my geometry students. We're going to talk today about writing equations for circles. This is really the last topic of this unit. And the reason why we're talking about equations for circles now is because it's based on the distance formula. So that's why we're writing them now. So maybe you wrote equations for lines in the past, like y equals mx plus b. Now for circles. Okay. So here we go. The most important thing about a circle is the center and its radius. If we know the center and radius, we can kind of develop an equation for it. So right here, this point right here is the center of this circle. It's located at 2, 2. And if we look here, going from here to here, we see that the radius is 4. So center is at 2, 2. These are like the two things we need to know for a circle. We need to know where to put the center if we were going to draw it. Then if we were using a compass or something like that, we'd have to know what radius to draw it. Okay, so those are two facts we have. Now, we want to write an equation for what any point x, y on the circle must satisfy. Every point on the circle is 4 units from the center. That's what a circle is. It's a set of all points the same distance from the center. So this circle is a set of all points that are 4 units from 2, 2. Okay, so we're going to write an equation for the distance. The distance from xy on the circle to 2, 2 must be 4. So we're going to use the distance formula. The distance from a point xy, it's kind of my generic point, to 2, 2 can be written like this: x minus 2 squared plus y minus 2 squared. This is an expression for the distance between a point xy in the circle and the center. And that distance has to equal 4. So any point xy on the circle must satisfy this. For instance, the point 2, 6 is on the circle. If I put 2 in for x and 6 in for y, you'd find that it works. It satisfies this equation. Now, this equation is perfectly valid, but normally we want to write this without the square root, so we square both sides. If we square the left side, the square root disappears. And if we square the right side, we get 16. So this is called the standard form for a circle. There's some other things: parabolas, ellipses, hyperbolas. Probably learn about next year, I hope. But the most basic one is a circle. All right, that's kind of it. And in fact, we're going to learn a shortcut in a minute. Okay, so we're going to use the distance formula to write an equation for this circle. So the first step is locate the center. The center is right here, and it's at 3, negative 3. Okay, then the radius. So notice I go to the right or up because we know what those distances are. This is 1, 2, 3, 4. So the radius is 4 again. And we want to write an equation that any point xy on the circle must satisfy. So any point, if it's on the circle, it's got to be 4 away from the center. Okay, here we go again. Distance formula. X minus 3 squared plus y minus a negative 3. I don't like y minus a negative 3. I mean, I could put that there. That's what we have. We got to subtract the y coordinate from this point. But that's the same as y plus 3. So I'm going to use y plus 3 here. It's a little bit nicer. Square. Subtracting a negative, same as adding a positive, equals the radius. So it's saying the distance from xy to 3, negative 3 equals 4. Now, we're going to square both sides. I'll actually write it this time. We're going to square that, and we're going to square 4. When we square a square root, we just get what's inside. And 4 squared is 16. Voila. That's an equation for the circle. So any point anywhere, in order for it to be on the circle, has to work in this equation. All right, next example. Here's another one. So first we want to find the center. This time the center is at 2, 4. It's a small circle. And just like when we're writing an equation of a line, we want the slope and the y-intercept. But for a circle, center and radius. Okay, and the radius is, so I'll label center first, 2, 4, and the radius is 1. I'll go up this time. The radius is 1. Here we go. So any point on the circle must be 1 unit from the center. So write an expression for the distance from some point xy to 2, 4. X minus 2 squared plus y minus 4 squared. That's the equation for the distance. That's the equal 1. Square both sides. One squared is 1. There's the equation. That's an equation for the circle. All right, now here's the shortcut. This is a standard form for a circle, okay? Usually we refer to the center as having coordinates h and k. So h and k in this formula, they're right here. That's what the center was. So if you go back and look at what we just did, these two numbers that go there and there are the x and y coordinates of the center. That's what h and k represent. And r is for the radius. Okay, so all we have to do is plug them into this standard form here. Okay, all right, so let's go ahead and try that. So we're going to use this. Now the distance formula wasn't that hard. It happens pretty quick, but this is even quicker. So let's see here. The center of this first one is at 4, 2. And the radius of this one is 3. So the center is 4, 2. 4 is what h is. And the y-coordinate center is what k is. So that's h and k. And r is 3. So let's put them into the equation up here. So we have x minus h. That's the x minus the x-coordinate of the center squared. Plus y minus k. Y minus 2 squared equals the radius squared, 3 squared, which is 9. Now, once you get used to this, this is really easy, but it's important for you to know that this came from the distance formula. So the way I did it the first time, you kind of really have to understand. And then once we get really used to this, you'll probably use the formula, this equation. All right, so here, the center of this circle is at -3, -1. And this time it looks like the radius is 3. Okay, so -3 is h. -1 is what they refer to as k. We have the three things we need, h, k, and r. So we just got to put together. It's x minus the -3 squared plus y minus k, y minus the -1 squared equals r squared. I'm going to make this a little nicer. X minus the -3 is the same as x plus 3. Y minus the -1, same as y plus 1. And 3 squared is 9. There we go. Okay, so we're going to have to understand both ways. You're going to have to understand how to write it from the distance formula, which really wasn't that hard. And you also have to kind of understand this pattern here, this standard form. One last one. So the center is at 2, 4 for this circle. My stuff keeps disappearing here. This is h, this is k, and for this one, the radius is 2. All right, so let's plug into the pattern. X minus the x-coordinate of the center squared. So that's x minus 8 squared plus y minus the y-coordinate of the center squared equals the radius squared. So x minus 2 squared plus y minus 4 squared equals 4. Okay, now, probably never seen this before, and so this was kind of really fast. But if you think about it and get the basic idea, you'll be in great shape for class. Here's the general assignment. So you can find the equation either way. I've demonstrated 2 ways. But just for your convenience, I put the formula here. So remember, the center is hk. So locate the center and the radius. That gives you hk and r, and plug into the formula. Okay, so just write the equations for these 2 circles. And everything will become clear in class. So if you got it now, great. If not, just give it a try, and we'll be going over this in class. I'll see you tomorrow.